Greetings to the esteemed judges. This is Ishan Choudhary with my partner Aditya Kumar Jha, and we stand before you today to unveil an innovative solution in the fight against glioblastoma, the most aggressive form of brain cancer. Our dedicated research has successfully developed an optimized EGFR specific drug, and we call it GliomaXin. This innovation holds the potential to transform the glioblastoma treatment, increasing the survival rates amidst the limited therapeutic options. Glioblastoma, characterized by the uncontrolled proliferation of glial cells, remains a formidable challenge in oncology. Current treatments, including surgery, is not completely possible due to the highly infiltrative nature of the disease, resulting in a median survival rate of just 15 months. This calls for an urgent need for a novel therapeutic strategy that can effectively solve this, driven by the crucial role of epidermal growth factor receptor or EGFR in glioblastoma by overexpression, central role in tumorigenesis, and potential for targeted therapeutic. We designed a potent and selective EGFR ligand. We utilized computer-aided drug design or CADD for GliomaXin to be a small molecule ligand with exceptional affinity and specificity to EGFR. We have even conducted the preclinical studies that have yielded compelling evidence of GliomaXin's therapeutic potential. More to be unfolded in the next slide.
The first step in the development of GliomaXin was the target identification. For this variant of brain cancer, we chose epidermal growth factor receptor as a target and developed a ligand for it using the method of scaffold hopping from MQL software. The results from the target purification for ligand preparation and the ligand's 2D structure identified are shown in the figures on the slide. Subsequently, two targets with 100% binding probability were identified, namely neurokinin 1 receptor and MAP kinase P38 alpha. Additional pathway analysis was also conducted to validate if these findings were accurate, and in conclusion, these two targets were finalized for further study. Next, through molecular docking, the drug complex with the lowest energy, minus 9.45 kilocalories per mole, was developed and then used for further molecular dynamics simulation in silico preclinical testing. Finally, in the preclinical testing, GliomaXin passed all the drug validations except for the GHOST test, in which the molar refractivity was 15 cubic meters per mole more than the designated limit, which however can be optimized over time. Moreover, it was also able to permeate the blood-brain barrier and had a high gastrointestinal absorption, which is necessary for drugs targeting brain tumors.
Thus, to conclude, the preclinical testing results for the identified drug candidate are very positive. The drug has good solubility, pharmacokinetics, and blood-brain barrier permeability, which means that it is well absorbed from the gut, distributed throughout the body, and reaches the brain. The drug is also lead-like, meaning that it has the properties of a successful drug candidate. GliomaXin's toxicity analysis and the drug likeliness show that the targeted approach to EGFR protein has minimal risks associated with it. At last, we were successful in finding and designing a promising drug candidate for the treatment of glioblastoma multiforme.